This is chapter 13 in the book, and the topic is Bitcoin and blockchain. So this chapter covers the Bitcoin system and discusses the different topics related to Bitcoin and involved in Bitcoin, and also blockchain that is used in Bitcoin. Blockchain has, after Bitcoin was introduced, blockchain got many other applications, but the main or the first time blockchain was introduced was in Bitcoin system. But in this chapter, we introduced blockchain in the concept of Bitcoin. So the first time it was introduced, it was in Bitcoin and how it works in Bitcoin. But just to let you know that blockchain is used in other applications as well. So the overview of this lecture is first, how we create a Bitcoin address. So in Bitcoin, Bitcoin is a cryptocurrency system. So you have transactions and you want to transfer Bitcoins from one account to another account, but we'll discuss like how a transaction works. But before you can make a transaction, you need an address. So first we will discuss like how someone can create a Bitcoin address, and then when you have Bitcoin addresses, how you can make a transaction, how transactions work. So from the payer to payee, and then we'll see that in a transaction you need to lock and then unlock, and like how do these two works. And after that we'll see that, okay, now that we have created transactions, how do we put the transactions in a block and mine a block, and what is the concept of mining in Bitcoin system. So we'll discuss blockchain and then the concerns that raise in blockchain system. So this is the overview of what we'll discuss here. I want to mention that Bitcoin is a very complex system, and it is hard to compress everything in one short lecture here. This lecture is more like a guide, like what are the good sources of information, like how you can learn more about Bitcoin. So here I give a summary discussion like how Bitcoin works, but I don't go through more details, and I introduce you other resources for each item, like how you can learn more, how you can get enough information for each of these topics. So these are the references that I highly recommend you. So I search for Bitcoin and different topics of Bitcoin a lot on internet, and these are the best references that so far I have found. Well, all the questions I had were answered in these references, so that's why I recommend you to go through them. So the first one is like a very simple video, YouTube video that discusses like how does Bitcoin work. It is prepared by this channel, and like this channel visualizes and explains complex math concepts in very simple method. So it's like it's a very simple and visualized introduction to Bitcoin system, but that is not enough for the purpose of like an advanced level work with Bitcoin. So this is just a very short introduction, but it starts from simple basic concepts up to more advanced topics, but it doesn't go through details of them. But you need to learn more details, like learn how the system works and how to implement, how to work with small scripts and programs, how to code these all the items in the Bitcoin. So this website is a very great reference, and it explains all the concepts required in Bitcoin in a very simple way, and also provides some YouTube videos. There is a playlist of 4 videos, and Greg Mocker, who prepared these lectures, he goes through the concepts that were introduced in this website in the YouTube video and explain them in a very simple way, from very basic up to very advanced topics, and I highly recommend you to watch these videos. So this is 3 blue and 1 brown, the channel that I explained earlier, that's like a very simple visualized method to like learn an introduction to Bitcoin. And then this is the website that was made by Greg Walker. So he explains all the concepts of Bitcoin in a very very simple way, and from like basics to advanced, and all the implementations as well. So you can go through the topics, and like from beginner to like you see that the topics are explained here, and very well designed. And then there's a guide here, and like again you can click on them and move forward. But what I recommend is that like here there's a YouTube link, and then you can when you click on it you can see the playlist. He has a playlist in Learn Me a Bitcoin, is that's the name of this website. And then this there are 4 YouTube videos, each one an hour and a few minutes, so like almost 4 or 5 hours to like you will learn everything about Bitcoin that you need. So in some topics that I will discuss in my short lecture, I will refer to these lectures, and like I highly recommend you to simply go through all these 4 videos, and you will learn everything about Bitcoin. It was very helpful for me when I went through them. In addition to these, this person, Greg Walker, he has another video. It is called Getting Started with Bitcoin. So it gives like an introduction how to start with Bitcoin, like how to create an address, like what are the applications that you may need to work, and like how to create a wallet, how to manage all the Bitcoin addresses that you have, and how to make a transaction, and what are the security issues. So all the topics that he will discuss are given here. So, and also he demos them, like how to work with those applications. So even like this is from a different aspect. In this video, he doesn't go through like the implementation and details. He goes through like how you actually work with the applications, like on your cell phone or your desktop. And if you want to buy a Bitcoin, what do you do? What if you want to sell a Bitcoin, or like if you want to like send some Bitcoin to someone, how do you do that? And all like the real, how do you work with that in an application? So this also is very helpful. So this is this one. And then there is also a demo that I'll discuss when we reach blockchain. This is a very, very simple website that demos like how blockchain and mining works. It's like quite helpful if you just look at that and see how like how the blockchain works. Okay, so let's move forward and see. So like as I said, this is a very compact lecture, and I won't go through a lot of details. Like these are the references that I highly recommend you to go through and learn. Basically, like this is the best reference that I found on the internet for to learn Bitcoin. Learn Me a Bitcoin is. It's just a funny name, but he explains everything in a very simple way, and he goes through all the advanced and even programming, and also provides tools, and we'll see like what kind of tools we may need. Okay, so let's start. How does the Bitcoin network look like? It's a distributed system. So if you compare it with a banking system, that like you have a bank at the center, it's a central authority, and the bank will issue the accounts, and people have like get an account from the bank, and they have like let's say a credit card number or a debit card number, and these are their accounts, and also they have passwords. So there is a central authority, which is the bank, and like the bank can monitor all the transactions made by the people, and people like the accounts, right? So you with your account will send money to some other some other account. So the transactions are between the accounts, and the one who monitors everything is the bank. So that is how banks traditionally work, but Bitcoin is a different system. There is no central authority, and the identity of people is not like clearly given. So it is a distributed system, and there are some nodes that we call them full nodes. These full nodes, they exchange all the transactions made by people, and anyone who make a transaction, they distribute them to the other nodes. So when you are part of the Bitcoin network, you will see that you are connected to some nodes, or automatically, like you will be connected to some nodes. So each node has connection to some other nodes, and eventually through your neighbors and the neighbors of neighbors, you have connections to all other nodes. So there are some nodes that we call them full nodes. They they help distributing all the transactions, and this looks like a full node, and they distributed the transactions. And also when a block is created, block of transactions is mined by a miner, then they add that to the blockchain, and they have the blockchain as well. So each full node has one copy of the entire blockchain. So you see that these are the full nodes, and each one has a copy of the entire blockchain. So the blockchain right now is roughly about 250 gigabyte. I don't know. I think that this number was in 2019, probably at this time that I'm recording this, or at the time that you are watching this video, it's more. But you can say like some like probably at most 500 megabytes. It's the size of the blockchain. So this is the size of the blockchain that we have. So if someone, some node want to be a full node, they have some. Then it needs. It has some requirements that some memory that you can store the entire blockchain. I think the requirement is like 500 megabytes, and also some memory that you temporarily store the current transactions that have not been added to the blockchain yet. So when someone creates a transaction, they distribute these transactions, and they will be stored in the memory pool of the full nodes. So you see that each full node has a memory pool, and these are the is a pool of transactions that have been distributed in the Bitcoin network, and they have not been added to any block yet. They are not in any block yet. So when you add something to the block, then if the transaction is already in the block, then as soon as this node receives that new block, then they will remove that transaction from the memory pool. So the memory pool is like a temporary place to store those transactions that have not been added to the blockchain yet. So these are the full nodes, and as you see that there are connections between full node, and anytime someone creates a transaction, the full nodes will distribute that, this node will broadcast it to its neighbors, and then when this node receives that, then it broadcasts it to other neighbors, and immediately it will be broadcast in the entire network. So almost 8K full nodes are available in Bitcoin at this time, or probably more. But the majority of people who work with Bitcoin system, they don't actually use, they are not full nodes. They are something that we call it a lightweight client. So for instance, you install a wallet on your cell phone or on your laptop, for instance, and then you simply connect to a full node, and anytime the full node receives something that affects your wallet, your Bitcoin address, then it will let you know. Or if you make a transaction and you want to distribute it in the Bitcoin network, you will send it to the full node or few full nodes that you are connected, and then they will do that for you and they will distribute your data. So the majority of clients that connect to the Bitcoin network, they are lightweight clients, so they are not shown in this picture. So as I said, like many full nodes and so many other lightweight clients. So it is important to learn the concept of like memory pool and blockchain. So the blockchain is like a permanent location that we have already put the transactions in a block, and the block is confirmed, and we store that in the blockchain. Although we'll later on we'll see that the blockchain, it takes us some time that we finally confirm the last blocks, but the earlier blocks are already confirmed, and we never change them. But a memory pool is a temporary place that is a pool of transactions, and anyone who want to add, create a new block, they will use the transactions that are available in this pool. So if someone want to make a block, then they refer to this memory pool, and they see that how much transaction fees are paid by each transaction, and they typically choose the transactions that have paid the highest. So we'll discuss that, like how that works. So with this background, we move forward to the topics in the Bitcoin system. So the first thing, if you want to make a transaction, the first thing you need is a Bitcoin address. So you have a Bitcoin address, like a very simple transaction. You need a Bitcoin address as a payer, and you have someone that you want to send this some batch of Bitcoins to, and that person also has a Bitcoin address, and then you make a transaction sending a batch of Bitcoins from your Bitcoin address to the payee's Bitcoin address. So the transactions are like a very simple way to describe a transaction is that transfer some Bitcoins from one Bitcoin address to another Bitcoin address. The main benefit of using Bitcoin system versus the traditional banking system is that in Bitcoin, the owner of the transactions, or the owner of Bitcoins, is anonymous. We don't typically we don't know. Like it is possible. It is transparent. Everyone can see like who. What transactions are there, like the blockchain is not hidden, like everyone can refer to the blockchain and see like what are the transactions, but the transactions are between the Bitcoin addresses, and it's not clear for people like who is the owner of one Bitcoin address. Perhaps if you want to send some Bitcoins to some other person, you may know that person or that institute that you are paying to, but that is the only way that you may know someone's Bitcoin address. So anonymity is the main benefit of Bitcoin system. In addition to that, like as I said, transparency, that like in a traditional banking system, everything is hidden, like it is stored in the bank database, and only the people who have the authority can who have access to the database or you can see like what transactions you have made, but and also the bank can see that. But in Bitcoin network there is a transparency, like everyone can refer to the blockchain and see like what are the transactions made in Bitcoin. But the problem is you don't know who has sent data to someone else, because all the transactions are made using Bitcoin addresses. Some Bitcoin address sends data to some Bitcoin to some other address, so we don't know who is the owner of that address. And also the owner is like one person can have multiple addresses. It's not like you create one address and always use that. For anonymity, you would rather to use different Bitcoin addresses. So it's like a perfect anonymous system that you make transactions and no one knows that that you are the one who made these transactions. So that is the main benefit of Bitcoin system. So now let's see actually how we create a Bitcoin address. So we need two basic topics, public key and private key system, and also hashing. So in public key crypto, we, in a very simple way, each person has a public key and a private key. Clearly from the name, this like the private key is private. You never share it with anyone. You always keep it with you, and you store it in your own system. If you have a wallet, I frequently refer to the wallet. Wallet is an application in your system, and you store your Bitcoin address in the wallet and all the transactions that you have made with this Bitcoin address, and also all the Bitcoins that you received. So sort of like you like manage everything about your Bitcoin address in that wallet. So you store that in your private in your wallet. The private key will never be shared with others, but public key is the thing that you'll share with other people. So the way it works is that if I want to like send, or someone want to send me some number of Bitcoins, and like I ask them to lock it or encrypt that with my public key, and when I receive that, I decrypt that with my private key. So since like I don't share my private key with others, but I can simply share my public key with others. So others have access to my public key. They encrypt that with my public key, and then when I want to use it, I decrypt that with my private key. So that is like the very basic concept of private key, a public key crypto. But you need to know the concept of public key crypto. Otherwise, you will have difficulty with learning Bitcoin. So I highly recommend you first go through the public key crypto and then move forward to the Bitcoin system. So public key crypto has different ways, like there are different methods to create a public key. As like you need a pair of public key, private key for each person. So the common method in networks is RSA, but here in Bitcoin system we don't use RSA. We use elliptic curve crypto, and it is the acronym is ECC. So it looks like a curve. So you see that this is the curve. Well, not exactly like this. There are different curves. The one that is used in Bitcoin is called SECP256K1, and it looks almost like this. And there are very interesting properties of this curve that will be are useful in Bitcoin. So the reference website and YouTube videos that I mentioned earlier, they explain with a little bit more details that are like how it works. But here, like I briefly mentioned how it works. Like this is the formula for the curve that is used. That you actually, when you use Bitcoin, you don't need to know that. This is just like for your information. But what we do is that we create, when you want to create a Bitcoin address, you choose some random number. You use a secure random generator. Remember that like each random generator needs a seed. So your wallet asks you to like it suggests you some seed, and that seed is a very large statement, and it's unique in the world. So it is secure, and it's very unlikely that someone else can have used the same seed. So with that seed, which is unique in the network, and the very large size of the random number that's generated by that seed, then it is almost impossible that two different people or two different accounts have the same private key, private key. So the private key, as I mentioned earlier, is just a random number created by your wallet. So a 32-byte random number. So here you see that we demonstrate the number in hexadecimal. Hex numbers are base 16 from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F. So 16 digits from 0 to F, and then so with 16 symbols or characters that you have in hex, then for each byte you need 2 characters, right? So like for instance, like here, this is 1 byte. 1 character is conversion between like 4 bits binary. So 0000 in binary is converted to 0 in hex, and then 0001 is converted to 1 in hex. Or so like you see that, for instance, F is 1111 in binary. So this is 4 bits in binary, and we convert it in 1 character in hex. And then B is another 4 bits in binary, and we convert it to 1 character in hex. So this is 4 bits in binary and 4 bits in binary. So 4 plus 4 is 8. So 8-bit is 1 byte. So 2 characters in hex, and they create 1 byte. So this is how we demonstrate that. So each of these items that are separated with columns are 1 byte, so containing 2 characters in hex. So we see that we have 32 bytes here. So the private number is a random number with 32 bytes. So with 32 bytes, we have 256 bits. So the total number of private keys that might be created are 256, which is a quite very large number. Like every single particle in the world can have a private number. So it's a very large number. So you will never worry about that. Like if someone needs a private number and you run out of the number of private keys. No, it's very large, and it's like, you cannot imagine how large this number is. So that's why like everyone with no worry can create a new private key, and even like each person may have multiple Bitcoin addresses, so for each one creates a private key. So at this point, let's assume that we are working on 1 pair of private key public keys to create 1 Bitcoin address. So you generate, or your wallet, actually the application that you have downloaded for wallet, it generates some private key. It's a random number, and then it uses the math behind the elliptic curve crypto to figure out what is the public key. So the public key, so like very briefly, we start with this point. Always we start with this point, and then like we find the tangent, and then based on that we find some other point in the curve, and then like we do that again and again. So we hop from this location to another location, different coordinates on the curve, and then we do that as many numbers as we have in the private key. This is a number, right? Well, we demonstrated in hex, but this is a number. So we do that as many numbers as given in the private key, and then we finally reach some point. So let's say this is the point that we finally reach. This is it has a coordinate x and y, so it's going to be our public key. So this is how we demonstrate the public key. So the yellow part is the x, all right? So 32 bytes, the x value, and then another 32 bytes, the y value of that. So, and here it says, like the book describes like what OpenSSL commands that you need to run to like create some private key if you want to do that. But typically, like people, when they do that in they download the wallet, and like then it automatically generates that for you. But here we generally want to describe like how it works and what is the meaning of these numbers. So you have 32 byte x and 32 byte y. But like if you look at this, for instance, for this particular x, right? So this is the x axis, and then you see that here If you know the X, then you can simply figure out what is the Y. But there are like, because the curve is clear, we know that what is the curve, right? So this is the formula for curve, and the systems can simply figure out if we know what is the X, then we can simply figure out what is the Y. But there are two Y's, right? There is a positive Y and a negative Y. So for instance, if we look for this particular X, we assume that, for instance, like here is 1, 2, 3, 4.7 or whatever, like let's say 5. So, but there is a positive 5 and negative 5. We don't know which one it is, right? So if we mention the number here, you clearly know what is Y, but I say that is like redundant, because if you know the X, then you can simply refer to the formula and figure out what is Y. So initially, when the Bitcoin system was introduced, people like it was introduced with this format, but later on they tried to make a compressed version of this. So they said, like, why do we store Y? We can simply store that, we can store only X and then figure out what is Y. This is like when we compress that, so this, okay, so this is the compressed version. So if it is not compressed, this is like the original way to store a public key. As I mentioned, public key is just a coordinate on the curve, right? So it is not compressed. We put a prefix 04, and it means that it is not compressed, it's uncompressed. And like if you look at the earlier transactions in very early transactions in Bitcoin, which was started in 2009, so you see that at that point transactions where they use this type of public keys, but then later on they changed this to compressed, and then they didn't use this format anymore. They use the compressed one. So there is a very interesting property of elliptic curve with this formula, and when it is defined in finite fields, that if it is so the Y value, if it is a positive value, then if it is an even number, then it is a positive value. It's like above X. But if it's an odd number, then it is a negative value. It's below here. That's an interesting property of this curve, and we use that. If, like for instance, here you see that Y is ends with D7. So 7 in binary is 0, 1, 1, 1. So it ends with 1. It's an odd number, right? So when we want to compress this, we remove this blue highlighted item. And we say, so since it was an odd number, then this is a negative number. And then what we use for that is we use prefix 03. So when we enter prefix 03, it means that this is a compressed one. We enter only X, we didn't enter Y. Because simply you can refer to the formula and figure out what is Y. And Y is a negative number, right? So 03 means that Y is a negative value. And if we use 02, then that means it is compressed and the Y is the positive value. So you see that if you have this particular X, you have like a positive Y and a negative Y. So if you want to use the compressed way to demonstrate some public key, then you have to mention that whether you mean the Y value is the positive one or the negative one. So you use the prefix. So 02 for positive and 03 for negative. And what is 04? 04 means that you didn't compress that, right? This is like you enter both X and Y. So it is uncompressed. And also, like here it mentions like what type of, like there are many different types of elliptic curve formulas, and we use this one, right? Which looks like this. So the other ones look a bit different. But here, this is the one that is used in Bitcoin. So now that we have this number, like here you see that like there is a column between bytes, so you can remove these columns, and then you get a number starting from 03 prefix, and then 32 byte the number, the X value. So that's going to be this like this number is our public key. So then let's recall that we want to create a Bitcoin address. Bitcoin address is not a public key or private key. We use them to create the Bitcoin address. So then you can run this, and I'll explain that in the next slide, and that how you can use this public key to reach a Bitcoin address. So what you need to do is that to hash this value. So what is a hash value? Hash is a one-way function. So in a hash function, you have, like in any function, you have some input and some output, right? Typically when you give a value as an input to a function, then it gives you an output. So from an input, you know what is the output. Typically, it's easy to figure out, like if you have the output, it's easy to find out like what is the reverse type of function and figure out like what was the input of the function. But hash function is type of function that it is impossible to figure out what was the original value, what was the input of this function to get this output. And also the output is always a fixed size number. So there are different types of secure hash functions. Here I don't want to go over like details of hash functions, but only mention like what are the hash functions that we use. You only here I only mention like what is the meaning of hash function and what hash functions do we use. So just to simplify that, it's something that like you give an input and it the hash function, you run the hash function, you feed the hash function with this input, and then the output will be a fixed number. It always gives you this fixed number, but there is no, if you have the hash value, which is the result of this hash function, it is not possible for you to figure out what was the input of this function, what was the value that you fed this function with. The only way is that you go through all possible cases, all different cases that might be available, and then it could be like billions of numbers, and then like see which one matches. So there's no like systematic way to go in a reverse way. So now let's see what are the steps to find out the Bitcoin address using a private key and public key. So we learned that for private key, private key is simply a random number. So you give a seed number to the your wallet, and then it generates. Your wallet is a random generator. It has a random generator, and it generates a private key, which is a 32-byte number, which is a quite large number. And then this wallet applies elliptic curve, and then calculate some public key, right? So this is your public key. So again, the X coordinate is 32 byte, but we need a prefix, which is 1 byte. So 1 plus 32 is 33 if we use the compressed demonstration. So typically, these days, we don't use the uncompressed one. So then you have a public key, so 33 bytes. Then you give it, you feed a SHA-256, which is a hash function, a secure hash function, and it gives you some result. It's again 32-bit, and then you feed that to ripen the 160. This is another hash function, which is its output is smaller. It's like the output of a secure hash function is always a fixed size. So the output of SHA-256 is 32 byte, and the output of this hash function is 20 bytes. So the output here is 20 bytes. So we call it double hash, or it's a fancy name like hash 160. Which means that we first run a SHA-256 and then ripen the 160. So the hash, and then the result is fed into the next hash, and then we do the hash again. So this is called double hash. And then now we have this hash value, its size is 20 bytes. Then we add a prefix to that, 00. Later on, you'll see that when you create a transaction, it depends what type of transactions you want to run. Like if, so there are two types of common transactions, like in P2PH, and the version number for that is 00. That's like the simplest way to make a transaction, but more complex transactions are P2SH, and the prefix for that is 05. So later on, when we learn about transactions, then we'll see that what is the meaning of them. But it's fine to just like say if a simple transaction that commonly used by people, we put the prefix 00, and for the more complex ones, we use prefix 05. And these correspond to those type of scripts that are used in transactions. So then we have a prefix and 20 bytes. So prefix is 1 byte, 20 byte, the hash of this value. And then, so this is going to be supposed to be our Bitcoin address. But the problem is here, if someone makes a mistake when they enter this 20 bytes number, which is like a very, quite large number, right? So if you want to enter the public key hash of someone and you want to send them some Bitcoins, if you make one mistake and, for instance, instead of 1, you enter like some other character, then in that case, you are sending data to someone else, some other Bitcoin address. Or even if that Bitcoin address is not available in the Bitcoin system, it will be lost. So you don't want that happens. So we want to make the public key or the Bitcoin address, you want to make it smaller. It's like 21 byte is quite large. And also, if you made some mistake, you want some systematic way to figure out like a mistake was made here. So one method in computers that we use to detect errors is checksum. So here we use this method, like checksum is introduced in network course, like for different layers of network, we use checksum. That is a very simple way. But here, the checksum that we introduce here is quite different, but the concept is the same. So like how do we use it is different, and the size, and but the concept is like checksum is always used to detect errors. So if you enter some Bitcoin address and there is some mistake in these characters, that it automatically, the system can figure out that this is incorrect. So how do we do that? Now that we have this 21 byte, so one prefix 00 is 1 byte, and then 20 byte public key hash, then with this 21 byte, what we do is that we feed it to SHA-256, and it gives us some output, and then we feed it to another SHA-56, and it gives us another 32 bytes number. So then we take the first 4 bytes of that 32 bytes number, and that's going to be our checksum. So now we have our Bitcoin address in hex, the number, right? So we have 00 public key hash and the first 4 bytes of this that we call it our checksum. So now we have this number, and then when we give this Bitcoin address to someone, and they can simply, when they get this Bitcoin address, they can simply run SHA-256 and then again SHA-256 on the output, and then they, if there is the number get here, if there is, it doesn't, when we calculate that, if it doesn't match, the first 4 bytes doesn't match the checksum that is given here, then we can simply figure out, oh, there was some mistake, like, it doesn't match with the checksum that's given here. So anytime you receive a Bitcoin address, like you take the first 24 bytes of that, and then you feed it to SHA-256, and the result is fed to the another SHA-256, and the first 4 bytes will be compared to the given checksum. And if they don't match up, that means that this Bitcoin address, there has been some mistake in this Bitcoin address. So this is like a systematic way to figure out that whether there is an error in the Bitcoin address or not. So far you got a number which is like, okay, 1 byte here, 20 byte here, and 4 more bytes here, right? 25 bytes, which is quite a large number. So how can we make this number shorter? So we changed the demonstration of this number. So this is okay, 25 bytes number. So you can demonstrate it in binaries because it's going to be very large number, right? Because the range of numbers that you use are only zeros and ones. You can demonstrate it in hex number, right? So in hex, then how many characters? If there are 25 bytes, 25 times 2, you have 50 characters that you use. Or you can use another basis. So there is another base called base 58. So the base 58 has like 58 characters and symbols to demonstrate a number. So when you convert the number from hex to base 58, then the number going to be shorter. So if you want to demonstrate this number in binary, that's going to be a very long number. If you demonstrate it in hex, it's like average size, but still large. But if you change the base to 58, then it's going to be shorter, much shorter than this number. But you see that the characters are used in base 58 are not limited to only 0 to 9 and A, B, C, D, E, F. There are like other characters here, right? See like big V and then like little y, and all like alphabetic characters are used. If you like simply check Wikipedia and see like what is base 58 encoding, you can see that. But there are many online tools, and also the website that I introduce you, Learn Me a Bitcoin, that it simply gives you like a tool that you give it a hex number, and it converts that to base 58 encode number. So now that you have this number base 58, that is your Bitcoin address, and then like you can simply convert it to a QR code. So there are online tools that you give a base 58 number, and then they convert it to QR code. So if you like, let's say you want to pay someone, transfer some Bitcoins to someone, then you ask them to give you their Bitcoin address. So they can give you the Bitcoin address in base 58 format, or like simply if you use your cell phone, you can scan their Bitcoin address, or let's say in their website they give this QR code in this format, and then you can use your cell phone to scan this. So you will know who so you know that this is the address that you want to transfer your Bitcoin to. So you can simply scan it, and then you will transfer your money, your Bitcoins, to this Bitcoin address. So that was the first part of our lecture here. So here there is some discussion like how base 55 works and how you can convert it, or you can simply use the tool. The book gives you like some web page, the address, like you can download that tool and run it in Python. Python has the tools, and also that website that I introduced has a tool that, like, there are many tools available online that you can do this conversion, so you don't need to go through details of that. Okay, so that was the first part of our lecture, that like, okay, how do we create a Bitcoin address? So for the next step, we want to talk about transactions and see like, okay, now that we have a Bitcoin address and we want to transfer some Bitcoins to someone else, then how do we make a transaction? How do transactions work? Okay, recall that this Bitcoin system is different from traditional banking system. So in a traditional bank, when we make a transaction, the bank monitors and controls all the transactions, and they know that the one who makes the transaction, they have enough amount of enough money in their account, and when they want to send some money to someone else, make a transaction, they have that much money, and also everything is private, and only these two people and the bank can see that this transaction has been made. But here, recall that Bitcoin system is transparent. Everyone can see what are the transactions. So we want to make sure that it is safe, and and also it's like everyone can see all the transactions. And in addition to that, it is anonymous. Like people, although they see the transactions, they don't know who are the owners of these transactions. And more important, the most important thing here is that if this person or this the Bitcoin address is transferring some Bitcoins to some other Bitcoin address, then this is the owner of this Bitcoin address is the only one who can spend this Bitcoin, right? So when we send this Bitcoin here, only the owner of this Bitcoin address is able to spend this Bitcoin later on. And also, like if this person cannot spend this money multiple times, or like double spending is not possible. So these are the important things, that only the owner of this batch of Bitcoins is able to spend this money, and also it is now possible for this person or this institute to spend this money multiple times, or like something that we call it double spending is impossible. So these are the main important things that are covered or handled by the Bitcoin system. So how do we do that? When we want to make a transaction, like transactions could be very complex. Here, let's start with a very simple transaction. Let's assume that we have a batch of Bitcoins in this Bitcoin address, and it has some owner, and then this person or the owner of this Bitcoin address wants to transfer these Bitcoins to some other Bitcoin address which has its own owner. So what I do is that, like, when I want to make this transaction, I ask the owner of this Bitcoin address to give me some information. Typically, this information includes the public key of this Bitcoin address, and I ask them to send me this information. So then when I want to make this transaction, I lock this batch of Bitcoins with the information of the owner of this Bitcoin address. And then later on, when this person want to like spend this batch of batch of Bitcoins, and they need to unlock it. So we make it safe in this way. So we provide security in this way, so they don't allow others to spend this money. Only the owner of this batch of Bitcoins is able to spend that money. And later on, we will see that how we can prevent this person to double spend or multiple spend this batch of transactions. So as a summary, systematically, Bitcoin system provides anonymity. We don't know who are the owners of these Bitcoin addresses. Perhaps only the owner of this one knows that I'm receiving this money from this person, and the owner of this Bitcoin address knows that I'm paying to this person. And also recall that I mentioned earlier that one person may have multiple or like even like thousands of Bitcoin addresses, so for anonymity, so they don't make transactions with the same Bitcoin address. So for each transaction, they may create a new Bitcoin address. So it is anonymous. Like like even at this point, you know that the transaction was made to you, so you know that who paid you, but like that person will not use this Bitcoin address anymore. So like you don't know that whether that person are like having any other transactions in the Bitcoin system or not. So anonymity is very important. The more important thing is that this transaction locks this batch of Bitcoins, and only the owner of this batch of Bitcoins is able to unlock it. So this is the most important thing about transactions. Like, how do we lock and then when we want to spend it, how do we unlock it? So we'll talk with more details later on. So the components of transactions, as I said, transactions are not as simple as a bank transaction. So like only like one account is transferring data to some other account. So in Bitcoin system, there might be multiple safes, or like we call them safes. So like here, when you pay some other Bitcoin address some amount of Bitcoins, then we call it a safe, or at least this is the term that used by the book. So then when you want to make a transaction, you say that, okay, in this safe I have some batch of Bitcoins, and in another safe also I have some batch of Bitcoins, and then I collect these two and I have a larger batch of Bitcoins, and then I want to pay like 3 people. Like the person 1, like a Bitcoin address 1, and address 2, and address 3. So you see, there isn't it's not like a traditional banking system, like one account pays another account. It's like there might be multiple inputs and multiple outputs. So like here you can say that you create a transaction with 2 inputs, and there are 3 outputs here, like you pay 3 different people. Okay, so for example, let's assume that Alice bought something, and like Alice needs to pay Bob, but also like there has been an agent there, like Charlie was the agent, so Alice needs to pay both Bob and Charlie. So Alice tries to figure out, okay, so first of all, like how much do you want to pay? So you want to pay 2.5 Bitcoin to Bob and 0.5 Bitcoins to Charlie. So Alice tries to figure out like how many, what are the Bitcoins that she already has in other transactions. So from the last transactions, like for instance, let's name them T1, transaction 1, and transaction 2. Alice knows that I have 2 Bitcoins here and 1.5 Bitcoins here. So in total, it's going to be 3.5, and I will collect these 2 and use it in this transaction. So, but you see that I need 3.5. Well, I have 3.5, but I need 2.5 plus 0.5 is kind of 3. So I have 0.5 extra. So what can I do with that? So when you make a transaction and you need to unlock these ones, right? So you unlock this safe and unlock this safe, and the amount of money is available in these 2 are in total is maybe 3.5. So you have to spend all of that. If you don't need that much, then the remaining, the leftover will be you can pay it to yourself, right? So like Alice pays that to yourself, and we call it a change. So 2.5 we pay to Bob, 0.5 we pay to Charlie, and there remains 0.5, but you see actually this number is not 0.5, we'll talk about that. So there remains some leftover, and we pay to ourselves. So you have to spend all the money that you have collected. So the inputs of these transactions are actually the outputs of some earlier transactions, right? So you take this output, basically everything is output, but well, we want to simplify it and say, okay, we take this output and we assume that this is an input of this transaction, but actually it's an output of the earlier transactions, right? So the output of this transaction will be the input of this transaction, and the output of this one is input of this one. So we say that transaction 1, and then we number the outputs, like index 0, index 2, so index 0, index 1, sorry. So we say transaction 1, index 1, we use it as an input of our current transaction, and transaction 2, index 0, the output, we would use it as an input. So these are the 2 inputs of the current transaction. Now we want to see, like, okay, what are the outputs of our transaction? So we pay this much to Bob, pay this much to Charlie, and then we have to pay the remain 0.5 Bitcoins, and we want to pay it to Alice. So, well, Alice is paying to herself. So this is the change, right? So, but we see that we don't pay the entire thing. We need to save some amount of money that we call it transaction fee. Like let's say in this case, like we consider this much 0.00003 bitcoins as the transaction fee. So well, who receives this transaction fee? The one who later on mines this transaction will receive that. Who mines the transaction and what is the concept of mining? Well, recall that like here we discussed in this picture that the full nodes will receive the transactions, but they don't. It doesn't mean that the transactions are immediately added to blockchain. The blockchain is where do we permanently store the transactions in blocks. So that's sort of our database. But when we receive a transaction, so I say someone creates a transaction and then that is distributed in the Bitcoin network. So everyone stores that in the memory pool, right? They don't store it in the temporary memory, not in the blockchain. So it takes, it needs some processing by some people who are called miners. So the miners need to like put these transactions in a block. The block size is predefined, like some number of transactions, like roughly between 1 meg up to 1.7 meg transactions could be in one block. So then they put these transactions in a block and then they mine it. It may take like 10 minutes, like roughly it takes 10 minutes for a lucky miner to mine that block, and we'll talk about that. And then you will have a block and you put it on top of the current blockchain as a new block. So as long as we have not mined that and it is not in the permanent blockchain, it's still in the temporary memory pool of the full nodes. So what is the incentive for some miners to do that, to put so much effort and like work a lot to mine a block? So one thing is the transaction fee. Like people voluntarily, they pay some transaction fee to the miner of that block. So they encourage the miner to put their transactions. So there might be like a lot of transactions here, but the miner chooses which transactions will be added to the blockchain. Or like to the new block that they will mine. So if your transaction fee is very low, it's unlikely that someone puts that in a new block and will process it. So your transaction fee should be high enough, like in comparison to the other transactions. It should be high enough such that like it is intensive for the miner to choose your transaction and put it in the block that they create. So that's why you have to put enough transaction fee. So you see that the total of these outputs is a little bit less than the total of inputs. So that difference, it goes to the transaction fee. So you don't pay it to anyone by default. Anything that remains, it goes to the miner of this the miner of the block that includes this transaction. So sort of you encourage the miner to include your transaction in the block that they mine. I guess like it takes 72 hours or like 3 days. So that your transaction remains like temporarily remains in the memory pool, and after that, if no miner chooses to include your transaction in some block, then it will be automatically removed from the temporary pool. So your transaction, the number of bitcoins or amount of bitcoins that you pay for transaction fee matters, and it should be like comparable. You compete with other transactions. Okay, so as I mentioned earlier, you have to go through the lock and unlock. So you see that this input is actually this output of the earlier transaction. So the person who created this transaction, right, this person has put a lock on this output. So if you want to use this, like let's say you are Alice, earlier when someone wanted to send you some number of bitcoins, they ask you to provide some information and they put a lock on this output. So now you are Alice and you are the only one who can unlock this output. And then if you can unlock it, then you can spend the money, the bitcoins in this safe. And then when you unlock it, then you can use it in another transaction. Then you have to, when you create a transaction, you first unlock this and you spend it, and then you want to transfer the money to this safe, and later, which belongs to Bob, right? So then later on, Bob needs to use this money. So how does Bob do that? So you have to lock this output to make sure that only Bob is able to spend this money. So later on, Bob uses its own information to, which is Bob's private key, to unlock this output. So at this point that you are creating this transaction, you use your private information to unlock this. Now you can spend it and you can transfer that money to these outputs. So you ask Bob, Charlie, and of course your own account. You already have that information. So you need to get the public key information of this Bob and Charlie, and then you can lock this. So it is locked, and if you put it in this transaction until at some point Bob want to spend the number of bitcoins available in this safe, and then they need to unlock it in the next transaction. So you see you have, like, when you create a transaction, you lock this, and then in the next transaction that Bob want to use this, Bob unlocks that. So you ask Bob to provide some information that you use to lock this, and then only Bob will be able to unlock this and spend the bitcoins in this safe. So the output has a locking script. So we call it a script because it's not a like predefined simple way. So like each application could be different. A very simple transaction could be like one Bitcoin address is sending data to some other Bitcoin address, but typically there are more complex scenarios. So like you may pay to a group of people, and you may need information from multiple people to to unlock this. So for both locking and unlocking, it could be quite complex. That's why we write like a short script to lock and then another short script to unlock that. So it is not like predefined. So the format of scripts are predefined, but they could be different for each transaction. So here you first lock in the output, and the owner of this safe later on can unlock it in another transaction and spend the money of this. So how does this unlocking script work? So it takes the locking script and it puts that like on the right side of this unlocking script. So when this person want to unlock this safe, so they take this unlocking script that they have made here, and then they take this locking script that has been taken from the last transaction. So from left to right, we run this. It's like a script very similar to a stack, and then when you run it, then you can unlock the lock, and then you are able to spend the money in this one. So recall it again, I mentioned this input is actually this output, right? So this is like the same safe, but in the last transaction, so you lock it, and in this new transaction, you need to run an unlocking script and take the locking script from the last one, and then you are able to spend the money in this safe. So some simple script examples. The first thing is like when you run that stack or run this script, unlocking script and then locking script. So what happens is that you have a stack, and then there are two items that you can push into the stack. Like there are some numbers that you can push into the stack, and then there are some scripts that you run, and when you execute them, you may push something into the stack and take off something, or like pop up some items from the script, from the stack, and run it. So we call them op or operations. So so for instance, look at this one. So if we assume that this is the locking that we call the locking script pop key, and the unlocking script seek. So when this is the locking script and unlocking script, remember that we put the locking script on the right side of unlocking, and then we run it from left to right. So for instance here, this is the lock and this is unlocking script. So we put this first, the unlocking on the left, and then the locking script on the right, right? So this is the combined script. So in the current transaction, we have this unlocking, and we run it on before locking, and then we what we intend is to unlock the transaction. So okay, now we want to run this. This is like a very simple transaction, like a script that it's like not a standard one. It's when we don't use it in real Bitcoin system. It's just to understand like how it works. So when you have some numbers in less than greater than, like for instance less 5 greater than, and then less than 95 greater than, these are like they are used to for numbers. So when we see this kind of format, it means that push it into the stack. So there's a 5, we push it into the stack, and then there's 95, we push it in the stack. So right now the stack is 5, and then on top 95, and then we have an operator. So then we execute this operator. So each operation is defined, like how does this operation work. So for instance, op add, how it works is that it pops 2 elements from the stack and add them, and then the result will be pushed into the stack again. So right now in the stack there's 5 and 95, and then we execute op add. So it's going to be like it pops the 2 items 5 and 95 from the stack. Well, 95 is on the top, so we first pop 95, and then we pop 5. So we have 2 items, add them, the result is 100, then push 100 into the stack. So now in the stack we have 100. Then we reach another number, then we push this element into the stack. So we have 100 again in the stack. So the stack contains like 100 and again 100. And then we execute this opcode. This is op equal. What it does is that it pops 2 elements from the stack and compares them. If the result is like they are equal, then it pushes true into the stack. And if they are not equal, then it pushes false into the stack. So then, okay, it pops 100 and 100 and compares them. Since they are equal, we push true into the stack. So now at the end, there is a true in the stack. So when we execute the entire script, then if the result is true, so true means like in number is like 1 or greater than 1. So if it is true, then that means you succeeded to unlock the lock, right? So this is a script that unlocks this lock. But if it is false, or there's nothing in the stack, so the stack is empty at the end, or there is some particular, or it's unmature, like there is some particular opcode which is called op return on the stack, then in those cases, you didn't succeed. The only case that you succeed is that when you are done with this script, there is a true or a 1 or greater than 1 on the stack. So that means you succeeded to unlock the lock. So that was a very simple like lock and unlock, and how we run the combined script. I don't want to go through more details, but they are necessary to understand how Bitcoin works. So now there are 2 common unlocking and locking scripts that are used. Like if you use a simple transaction from one Bitcoin address to another Bitcoin address, typically what you use is P2P Edge, or pay to public key hash, and these are the lock and unlock scripts. And if there are like multiple people who are the receiver of this Bitcoin, and you need some signatures of this group to unlock the lock, then in that case, this was introduced but not used. And this is actually the one that used in if the transaction is more complex and you are paying to a group of people and you need approval from some of those people, not all of them, or approval of some people, let's say 2 out of 3 approvals are enough to unlock the lock. So that's, you see, quite complex. So in that case, you use this type of transaction. So the two two very common ways to create a transaction is P2PH and P2SH. So this is for more complex ones, and this is for like more simple ones. So I refer you to this website and the video that explains the transactions. So like it goes through the details, and like it actually shows how they look when you execute them, how do they look in the stack, and like explains like why do we like move forward from one script to another script, and like what is the reason that these were introduced, and how do they work. So it is necessary that you go through the transactions video in this playlist and learn how transactions work. So, but here, like since in that YouTube video, it uses stacks, and it demonstrates, visualizes all of them. So I think it's the best way is that to go through that video and watch them. But it is necessary to understand how a transaction works. Also, this website, the Learn Me a Bitcoin, has an explorer that visualizes the transactions and blocks. So you see that these are the most recent blocks that have been mined in Bitcoin. So these are like live blockchains, and like the real blockchains in the Bitcoin system, and then like the temporary pool. So you can see what are the transactions that are currently available. And like for instance, it gives you some. So if you click on it, then it gives you more details about that particular that block and the transactions and the code for each transaction. So it's really good that it visualizes everything. In addition, if you like refer to the common websites like blockchain.com/explorer, if you enter that blockchain.com/explorer, you can see that like all the recent mined blocks, and if you move forward, you can see all the other transactions, or you can search a block or transaction. So you see that the blocks are given here. So the transactions that are already put in a block, and they are included in some block. So the blocks are given, or you can click on transactions and you see that what are the transactions that are still available in the temporary pool, not been mined yet, or you can like search some transaction and it gives you that information. For instance, like you can click on one transaction and you see that like the details of that transaction. So like how many Bitcoins from in the input and output, and what was the fee, and like what was the outputs of this transaction, what was the inputs of the transaction. So all the information about the live transactions are given in this website. So blockchain.com/explorer, you start with that, and then like you can search for transactions, search for blocks, so you can click on blocks or click on transactions. And it also gives you more information on like what are the average fee, average value, and the other information that you may want to know. Once a node generated a transaction, let's say this node generated a transaction, then it broadcasts that transaction to its neighbors, and then each full node who receives this transaction It verifies whether this transaction is correct or not, like whether the person who has spent this number of bitcoins was um, um, the person who was allowed to spend this number of bitcoins or not. So like the locking and locking is correct. So it verifies that. So you see that it's a lot of work for full nodes to verify all the transactions. So that they store that in their temporary pool, and then then they will broadcast it to other nodes. So these are what the full nodes do. And then there are lightweight clients that connect to these full nodes. And if there's some transaction that affects the lightweight client that connects to this full node, then it lets that lightweight client know that some new transaction shows up that affects your wallet. So then that lightweight client also will verify the transaction. So then you'll see that we will distribute this transaction to the entire network, and everyone receives that. With this verification, we make sure that only the owner of that Bitcoin was able to spend the money, and also we also check whether the Bitcoin has not been spent in the past. So the full nodes double check that. So you see that this is different from traditional banking systems. In the traditional banks, when a transaction happens, the bank monitors and controls everything. But here, like, it's transparent, and basically everyone in the network, all the full nodes, are able to verify, and they will do that. They will verify whether the transactions are correct or not. So the two main challenges that the producer of, the one who designed the Bitcoin faced was how to achieve the consensus between all these full nodes that are available in the network, and make sure that all of them, they have the same or identical data, right? So you distribute the data between all these nodes. So how do we make sure that it is like we have achieved consensus, and the data is the same, identical between all these nodes? Since there is no central authority who controls everything, so this is a distributed database. So how do we achieve consensus? That is one main challenge. The other challenge is that has been like how to prevent people from modifying the existing transaction. So let's say you have some transaction. So after a while, you change the transaction or remove that transaction. So you have spent your money, your Bitcoin, and send it to someone. Then let's say later on you will remove that transaction. So how could you prevent people from modifying the transactions or removing the transactions? So the method or the solution that was introduced in Bitcoin was a blockchain. So blockchain, as I mentioned earlier, was first introduced in Bitcoin, but now it has other applications. But let's see how blockchain works in Bitcoin. So first of all, blockchain is distributed, and like it will be validated by all the nodes, all the full nodes in the network. Whenever they receive something, they will validate the blockchain. And also it is append only. That means that so you see that each node has a copy of the blockchain, right? So it is append only. So you can only add a block on top of this blockchain or at the end of this blockchain. So you cannot like get back and modify anything. So if so we'll talk about that. So like, what if someone tries to modify something in this one of the blocks, and like what happens, like what should they do? And you see that it is impossible. So how does it work? How does this blockchain work? So this Bitcoin system in general works. There are some of these full nodes. They are miners. What does a miner do? A miner, look at this temporary pool. So you have a temporary pool of transactions in each full node. So if a full node decides to be a miner, then they go through these transactions in the memory pool and like collect some of them. It should be some size. It's like some certain size, not smaller than and not larger than some certain sizes. I think that roughly between 1 meg and 1.7 meg is the size of a block. So they collect these transactions, and then they try to create, they mine it. That means you want to make a block based on these transactions. You first you have to like validate all these transactions, and then you mine this like a block based on that.